We're starting topic 6 of chapter 1, solving equations and formulas. So we'll take a look at equivalent equations, the addition and multiplication principles used in solving equations, types of equations, and then solving various formulas for a particular letter. All right, we're going to start off with our matching, and we've set up sort of a procedure. We'll pause the tape at this time, and then when we finish, we'll have these words. But you should give it a challenge and or take the challenge and write them out. So here's what we have. When we solve an equation, we find its solution set. An equation that is never true is a contradiction. An equation that is true for all replacements is an identity. An equation that is sometimes true and sometimes false is a conditional equation. The solution set of the equation x equals x plus 1 is an empty set. And I don't know if you recall what an empty set looks like. It would be a set of brackets that has nothing in it. So that's an empty set. Another item that's used to indicate that is a 0 with a slash through it. So these are other ways to indicate an empty set. Equations that have the same solution are equivalent. As we go on, you'll see examples of these. As we go on to number 7, they're asking us to determine whether the two equations in each pair are equivalent. Well, we'd have to solve these equations, and in the first case, we have a negative x equals, we'll subtract 2 from both sides, and we're going to get a negative x equals 6. So x equals a negative 6 in this case. And here we're going to divide both sides by 5. And we get x equals 6. Well, since this one is a negative 6 and this one's a 6, they are not equivalent. Here we're going to divide both sides by 2, and we get t equals 5. And here we get 3t equals 15 as I do something. We'll be going over all these steps, so they've put this in here assuming you know how to already solve equations. And then we divide both sides by 3, t equals 5. So here t equals 5, t equals 5. These are equivalent. We'll just abbreviate that a little bit there. Okay. In class, we went over a number of techniques. And what we're going to do here is use the real basic technique of adding something to both sides so that we get the x all by itself. So here I'm going to add 3.1, and this side I'm going to add 3.1. Now, since this one's negative, 3.1 is its additive inverse. So this will just become x, and this becomes 7.8. Now in this case, we want to isolate the n by itself. And one of the techniques we went over in class was to, when we have that, we're going to divide both sides by the numerical coefficient of the variable, which is 6. So we divide both sides by 6, and we get n equals a negative 7. Now in this one down here, the first thing we want to do is to isolate the t. So we're going to add 8 to this side, add 8 to this side. So we get 3t. These cancel out, are 27. Now as we did up here in example 10, we're going to divide now both sides by the numerical coefficient of the variable, which is 3. So the 3's cancel out now, and we get t equals 9. One of the other techniques we mention, when there are fractions in an equation, we multiply every term by the lowest common denominator, which is a 2 here. So as we multiply this term, this becomes 4x. Here the 2's now cancel out, and we're just left with an x equals 20. Now this isn't the same equation, but it is an equivalent equation because we use one of the basic principles of multiplying every term by the least common denominator. And it's just easier to work. So we group like terms now. That's 5x equals, and I see I had a little error here. I meant to write 40 there. And now we divide again by the numerical coefficient. And we get x equals 8. And if we put that 8 into the original, it checks. Here we're going to use another technique, that is get rid of parentheses by distributing our 2. So we get 2x minus 10 equals 14. Now we're going to add 10 to both sides. And we get 2x, these cancel out, equal 24. Then we're going to divide both sides by 2. X equals 12. And a similar method here, get rid of parentheses. Now we're going to add 30 to both sides. We get 6y equals 46. And now we're going to divide both sides by 6. See, we're developing a little procedure. Here the 6's cancel out, and we get y by itself. And notice you can take a 2 out of each of these terms. So this becomes 23, and this becomes 3. and you can leave it in this improper fraction form. So before we go on, I'd like to review, now as some of these equations get a little more challenging, the things we do. Step number one, when we work equations, is we get rid of fractions. By multiplying every term by the lowest common denominator. This includes regular fractions and decimal fractions. Step two, we want to get rid of grouping symbols. So going over these, get rid of fractions, get rid of grouping symbols, combine like terms, transpose by subtracting or adding the additive inverse, or I'll be showing you another technique shortly, which we call transposition. Then isolate the x and solve for that x or y or whatever letter they're asking you to solve for. And then another good thing, if you're not using MATLAB, is to check it, because you want to be sure your answer is correct. So let's keep this up here for a few moments and go over to this example. Now there's no fractions, but there is a grouping symbol, step number two. So we get rid of the grouping symbol, 7x. Now when there's a negative in front of a parenthesis, we get rid of the parenthesis by just changing the signs. So this becomes a negative 3x. This becomes a positive 5. And this is 37. Now we're going to use step 3, combining like terms. So this then becomes a 4x plus 5 equals 37. Now this transposition, which is step 4 over here, is to take the positive 5, because we want to isolate the x term. We want to get this positive 5 in a sense on the other side. That is, transpose it. Now we were doing subtracting 5 from this side. So this is a very important shortcut, that if we want to take a term like a positive 5 and move it to the other side of the equation, the shortcut, and we call it transposition, is that as it goes from this side to that side, it just changes its sign. So notice it's the same as if we added the additive inverse to both sides. Here this cancels out, and on this side it becomes a negative 5. So we now have 4x equals 32. And we just divide both sides now by 4. And we get x equals 8. And we followed the steps. There were no fractions, but there was a grouping symbol. We combined like terms. We transposed. We solved for x. And we'll let you do the checking, otherwise it's going to take too long. All right, let's go on to this next one. Now notice there are no grouping symbols, but we do need to do number 3 over there, combine like terms. So this and this becomes 11m minus 3 equals 5m minus 9. And this is sort of like the middle step where you have a variable, a number, equals a variable, a number. And now what you want to do is to get all of the variables on one side. And you want to try to keep the variables positive. So I'm going to subtract 5m, or transpose the 5m, and then this becomes 6m. That is, I'm subtracting 5m, subtract 5m, I get 6m. Now I'm going to transpose this by adding 3. This now becomes a negative 6. So again, I'm not writing out that step, but I'm transposing. And as we develop our skill, that's sort of a shortcut you can use. And now we're going to divide both sides by the numerical coefficient of what is with the letter. So this becomes an m, and this becomes a negative 1. Now notice the signs. You have to be very careful. All right, let's go on to this next one in which there are fractions. So for step 1, we see we have a 3 here. Here we have a 5. So our least common denominator is going to be what? Between a 3 and a 5. And the answer is 15. Now the key is we have to multiply every term by 15. So this is one term, this is another, this is one term. Now here the 3 goes into there once. This is going to be 5 here. Nothing to cancel out here. This is once, and this becomes a 3. Now we have to clear parentheses with our new factor 5. So this will become 10n. 5 times 2n. 5 times a negative 5 is a negative 25. This becomes a plus 45 equals, now there's a 2 there, so we have to go 2 times 3 is 6, so it's 6 times n is 6n. 6 times 4 is 24. So we've gotten rid of the fractions. We now have an equivalent equation, and we need to combine like terms. So this is going to be 10n plus 20 equals 6n plus 24. Now notice I tried to keep my equal signs lined up, and they are in sequential steps. These steps that I take, and as I illustrate over here, these are called solving the equation. These series of steps following this procedure is called solving an equation. And now we're going to do step 4 over here. So I'm going to transpose this to this side. This becomes a negative 6n, gives me a 4n. This becomes a negative 20, so this becomes a 4 on this side. Subtract 20 from both sides. Divide both sides by 4. N equals 1. Now, if you haven't, somewhere in your notes, you should have this. I've often said that I give bonus points by knowing the steps for solving an equation on your test on Chapter 1. So it's probably good to have this written down, and if you can, memorize it. Now, for some of these, I'm not going to do every single one because they would take too long. The answers are in the back of this chapter in your booklet, but I'd like to show you 22. This is similar to what we did before, where we had to do this innermost parenthesis first, which I have here, where I've taken away the parenthesis, changed the signs, group like terms. Then I went a -2 times 2 gave me a -4, and then the 3, this became a -1 and a -2x. And to make a long story short, as you see the work, I ended up with this. Now I'll pick it up from there, because what I want to do is I'm going to add 4x here, and I'm going to add 4x there. Then I end up with the statement -2 equals 1, because these cancel out. Now, is this a true statement? And the answer is no, this is not a true statement. So this is a case where we have what is called a contradiction, or an empty set. There is no solution to this. Or you could write it this way as well. So even though it looked like an equation initially, it had the equal sign, when we did the steps of solving an equation, we ended up with a not true statement. Whenever that happens, the answer is an empty set, no solution, a contradiction. Okay. We're now going to move on to what is called solving for a particular letter. So let's look at number 23. We want to solve for the letter M. And there's the M right there. How do I get M by itself when it's with that X? And the answer is we divide this side by X, and if we do it to this side, we must do it to that side. So the X's cancel out, and our solution then is M equals Y over X. Now in number 24, we want to solve for R. Again, R is in the middle. It's this times this times this. We get rid of the Q and the X by dividing both sides by Q and X. So these cancel out over here, and we're left with R equals Y over QX. So these were sort of easy, but again, a technique needed to solve more challenging examples. Now here we want to solve for N. So in a sense, what we want to do is to multiply both sides by S squared. So here the s squareds cancel out, and we're left with n by itself, and this becomes s squared t. Just as if you were to solve by t, for t, you would divide both sides by s squared. So we're just reversing the process. So for number 26, now we want to solve for this t. So we want to isolate the t term. So we're going to transpose this from one side to the other. And this then becomes v minus 2x equals 20t. Now this is a critical step. You're going to see this frequently. You want to isolate your variable that you're solving for. You're going to transpose this. Just change its sign, bring it to the other side. Now you're going to divide both sides by the numerical coefficient of t. These cancel out, and t equals this. Now here we want to solve for c. So we're going to get 2c equals f. We want to get this to the other side as a negative 2d. The e to the other side as a negative e. And now you've isolated the c term. Just transposing this. And it's just that easy. And now you divide by the numerical coefficient. And that is what c equals. Now in example 28, we're getting exposed to a number of different things. We want to solve for this r. So we're going to multiply both sides by r, which is the common denominator. So we now get rn equals, so we multiply this side by r, we get rn, but on this side the r's now cancel out. So that's a plus b. Now we want to solve for r, so now we're going to divide by n. The n's now cancel out, and r equals a plus b divided by n. Now a little trick is when you see something like this up here and down here, you could just reverse them, but right now that may be a little early for that shortcut. So just do it this way, and it works out very well. Okay, now again we want to get rid of fractions, so we're going to multiply both sides by c, and we get cd equals, and again let me just put it there, the c's cancel out, and we get a minus b. But we want to solve for a positive b. So what I would suggest, and there's a couple of ways to do it, but perhaps the easiest way is I want my b to be positive. So I'm going to take my b from here and move it to the other side. So it now becomes b minus, I should say plus cd equals a. So reviewing, I multiplied both sides by the lowest common denominator, which is c. So I get cd. Here the c's cancel out, and I get this. I want my b to be positive, so I'm going to take it from this side, move it over there, it becomes positive, and that's what I have. Now I want to solve for B. So now I just take this, move it to the other side, and I get A minus CD. And I believe that's the one they gave in our book too. Exactly. Okay. Now for this one, notice there's a C here and a C there. So in order to isolate the C's, I have to factor it out. So I'm going to factor out a C. This leaves me with a 1 there, plus AB. Remember, this was the reverse of the distributive property we had earlier, that if we distribute that, we'd get this. But we want to get the C by itself. So now we're going to divide by this. Oh, I did something fancy there. Now these cancel out, and I get C equals K over 1 plus AB. That's a little challenging there. So once again, I had to factor the C out of there, and then divide both sides by this. In number 31, we want to solve for a positive y. So to get my y positive, I'm going to move it over to this side. I'm just transposing. I want to isolate that, so I'm going to bring the 7 over to that side, and I still have a 3x. Now I'm just going to divide both sides by 5. And I could do it this way, or I could have put it all over 5. Let me see how the book wants it. They want it all over 5. So it would be 3x minus 7 all over 5. Divide everything by 5 or this way. And for number 32, we want to solve for y again. We got the 2y over here. I'm going to transpose that as a positive x squared, put it in order, and then divide everything by 2. So y equals that. All right, I have a feeling this tape is getting to be a little bit long, so we're using this interest formula. They're giving us the interest is 105. The principal is 4,200. We don't know the rate. And it's a half a year, 6 months. So we put the half in as 0.5. So we divide both sides by this. That gives us the R. And if I do this, it's 2,100. And if I divide this by 2,100, I get 0.05, which is 5%. Here we're substituting the formula for a parallelogram. A equals BH. My area is 60. I don't know my B, but I know my height is 6. I divide both sides by 6. I get B equals 10. All right, this was a long tape, and hopefully you've picked up some good points.